If n is equal to 4, then this is 3. If n is equal to 2, it is 2. If n is equal to 2, it is 1. That means the value of n goes on decreases. So the factorial representation of n is denoted as n factorial or n factorial. An is equal to 2 into n multiples of 2. If you write put n is equal to n, an is equal to 3 plus an minus 1. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram PU College, the Temple of Excellence. Today in this session, I am going to take a second unit in Discrete Mathematics. That is, this is very simple unit. In this, you are going to study only two concepts, that is recurrence relation, recurrence, and the mathematical induction. So now let us discuss regarding the first part, that is a recurrence. So advanced counting techniques. So in this we are going to study in advanced counting techniques, we are going to study only two concepts, that is one is the induction process, another one is the recurrence process. Now let us come to the recursive definition. What is recursive? Sequence and recursive definition. Now let us consider, for example, consider the sequence C formed by all positive even integers, all positive even integers, positive even integers are 2, 4, 6, 8, 10. These are all positive even integers. Now let us represent this as E. So let us consider a set E is equal to, consider the sequence E is equal to the set of all positive even integers. Then this sequence can be specified explicitly as, this can be represented as E is equal to the sequence E is equal to A of n, an, sequence E is equal to an, where an is equal to, an is nothing but 2 times n for all n is greater than or equal to 1, for all n is greater than or equal to 1. So an is equal to 2 times n, because here the sequence formed by all positive integers is nothing but 2 into 4 into 6 into 8 into 10. Therefore, this can be represented as E is equal to an is equal to 2 into n multiples of 2. That is the multiple of 2. If you take n is equal to 1. So, if you put n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, etc. Then you are going to get the sequence an is equal to 2n, a1 is equal to 2 into 1 is equal to 2, and similarly if you put a2, n is equal to 2, 2 into 2 that's equal to 4. If you put n is equal to 3, 2 into 3 is equal to 6. So 2, 4, 6, 8, etc. all multiples of 2. That is denoted as an is equal to 2n for all n is greater than or equal to 1. So this is the another way of specifying this sequence is E is equal to A of n, where A1 is equal to 2. The first number A1 is equal to 2 and an is equal to an minus 1 plus 2, an minus 1 plus 2 for all n is greater than or equal to 2. This is the definition for a recursive relation. So that is E is equal to En. The another way of representing E is equal to an is where a1 is equal to 2 and an is equal to an minus 1 plus 2 for all n is greater than or equal to 2. So here the first term of the sequence is explicitly specified and the term after the term are specified by the rule, which indicates how we obtain a new term from the preceding terms, how we are going to get the new terms from the preceding term. This description of E by recursive method, this is called the description to get the value of E by recursive method, that is regarding this recursive definition. So therefore this sequence, therefore E is equal to an can also be written as an, where a1 is equal to 2 and an is equal to an and an is equal to an minus 1 plus 2 for all n is greater than or equal to 2. So see, if we substitute the value of n is equal to 2, if you put n is equal to 2, what you will get? A2 is equal to A2 minus 1 plus 2, that is nothing but A1 plus 2. What is A1? So here A1 is equal to 2. 2 plus 2 is equal to 4, that is A2. What is A2 here? So here, since from the previous A1, A2, A3, A4, etc. What is A1 here? A1 is equal to 2, A2 is equal to 4, A3 is equal to 6, 8, etc. See, from this sequence, an is equal to an minus 1 plus 2. If you put n is greater than or equal to 2, then you are going to get the same values. That is, a of 2 minus 1, that is a of 1 plus 2 is a2 is equal to 4. Similarly, if you put n is equal to 3, what you will get? A3 is equal to a3 minus 1 plus 2, that is a2 plus 2. What is a2? a2 is equal to 4 plus 2, that's equal to 6. 6 you are going to get. Similarly, if you put n is equal to 4, then you will get a4 is equal to a4 minus 1 plus 2, that is a3 plus 2. a3 plus 2, what is a3? 6 plus 2, that's equal to 8. This is how you are going to get the sequence. So this is called your recursive sequence. So here, that means here the first term of the sequence is explicitly specified. So we are going to specify the first term explicitly, and then the term after the term are specified by the rule which indicates how obtained a new term from the preceding term. So how we are going to get a new term from the preceding term. Okay. So this is the description of E by the recursive method. So this is the description for the sequence E is equal to an by recursive method. That's it. Now let us take an example. So in the examination, they may ask the question, obtain the recursive function or a definition for the sequence an for the following case. Let us consider the first problem. If an is equal to 5 times n, 5n means it is nothing but the multiple of 5. Okay, just find out and express in the recursive form. That's it. Okay. Now what is given here? an is equal to 5 n. Now let us take n is equal to 1, 2, 3, 4, etc. Now if you put n is equal to 1, a1 is equal to 5 into 1 is 5, and a2 is equal to 5 into 2 is 10. So we are going to express this 10 as 5 plus 5. Now what is 5? 5 is nothing but a1 plus 5. Similarly, if you put n is equal to 3, this is for n is equal to 1, n is equal to 2, and n is equal to 3. 5 into 3, that's equal to 15. 15 can be written as 10 plus 5. What is this 10? 10 is nothing but a2 plus 5. a2 plus 5. Suppose if you put n is equal to 4, what you will get? a4 is equal to 5 into 4, 5 into 4, that's equal to 20. 20 can be written as 15 plus 5. What is 15? 15 is nothing but a3. So here a3 is nothing but 15. So we can write a3 plus 5. Okay. So what are the sequence we are going to get? A1, A1 plus 5, A2 plus 5, A3 plus 5, etc. Okay. See here, if it is 4, we are going to get 3. If it is 3, we are going to get 2. If it is 2, we are going to get 1. That means one number less than this. So therefore, the last term we are going to get it is an minus 1 plus 5. That's all. An minus 1 plus 5 is the last term. So therefore, the sequence can be denoted as an is equal to an minus 1 plus 5 in the recursive form. So this is the recursive function for the given value an is equal to 5n. So an is equal to an minus 1 plus 5. So therefore, a1 is equal to 5 and an is equal to an minus 1 for all n is greater than or equal to 2. That's all. For all n is greater than or equal to 2, an is equal to an minus 1, and whereas a1 is equal to 5. See, if we replace, if you put n is equal to 2, 3 and 4 greater than 2, if you put n is equal to 2, you will get a2 is equal to a2 minus 1, that is a2 minus 1. What is a2? a2 is 10 minus 5, that's equal to 5 you will get. So similarly, if you put n is equal to 3, you will get a2. If you put n is equal to 4, you will get a3. So therefore, the required answer for this problem is sequence an is equal to an minus 1, where a1 is equal to 5 for all n is greater than or equal to 2. That's it. So if you do this much, definitely you will get 5 marks from this. Okay, that's it. Now let us come to the next problem. What is the next problem? An is equal to 6 to the power of n. So the sequence an is equal to 6 to the power of n. Now here an is equal to 6 to the power of n. You can take n is equal to 1, 2, 3, etc. Now if you put n is equal to 1, a1 is equal to 6 power 1 is equal to 6. Now put n is equal to 2. This can be as 6 square. So this is nothing but 6 into 6. 6 into 6 is nothing but a1, because what is a1? a1 is 6. If you put n is equal to 3, a cube is 6 cube. 6 cube means 6 into 6 into 6, that's equal to 6 into 6 square. 6 into what is 6 square? 6 square is equal to a2, right? Now let us put n is equal to 4. What is a4? 6 to the power of 4. 6 to the power of 4 can be as 6 into 6 cube. What is 6 cube? 6 cube is nothing but a3 here it is. So like that, if you substitute the value of n, so on, if you put n is equal to n itself, then we are going to get an is equal to 6 to the power of, yes, what we are going to get is this 6 as it is, 6 into c here. If n is equal to 4, then this is 3. If n is equal to 2, it is 2. If n is equal to 2, it is 1. That means the value of n goes on decreases. So here 6 into a times n minus 1. So an is equal to 6 times, therefore an is equal to 6 times an minus 1, right? Okay. Now let us conclude this. So therefore a1 is equal to, a1 is equal to 6 and an is equal to 6 times an minus 1 for all n is greater than or equal to 2. That's it. Okay. So this is how we are going to solve this problem. Now let us come to the next problem. Very important problem. An is equal to 3n plus 7. Now same. What is given? An is equal to 3n plus 7. Now put n is equal to 1, 2, 3, 4, etc. If you put n is equal to 1, a1 is equal to 3 into 1 plus 7, that's equal to 3 plus 7 is equal to 10. Now if you put n is equal to 2, then a2 is equal to 3 into 2 plus 7, 6 plus 7. 6 plus 7. Okay. Now what is 6 plus 7? 6 plus 7 is equal to 13. So 13 can be known as 10 plus 3. Right. What is 10? 10 is nothing but a1. This is a1 plus 3. Or we can also write 3 plus a1. Right. Now if you put 10 is equal to 3, then what you will get? 3 into 3 plus 7, that's equal to 9 plus 7. 9 plus 7 is equal to 16. 16 can also be written as 13 plus 3. What is 13? 13 is equal to a2. So this is a2 plus 3 or 3 plus a2 we can write. Suppose if you put n is equal to 4, a4 is equal to 3 into 4 plus 7, that is 12 plus 7 is equal to 19. 19 can also be written as 16 plus 3, that is previous term plus 3, that's equal to, what is 16? a3 plus 3, or you can also write 3 plus a3. So like that, if you write put n is equal to n, an is equal to 3 plus an minus 1. 3 plus an minus 1, that's it. Okay. Now conclude this. So therefore, for the sequence here an is equal to an minus 1 plus 3, therefore a1 is equal to 10, an is equal to an minus 1, that's it. a1 is equal to 10 and an is equal to an minus 1, that's it. Okay, hope you followed. This is an is equal to n minus 1 for all n is greater than or equal to 2, that's it. Now let us take next problem. These are all very important for 5 marks. You may expect one question for 5 marks. So if an is equal to n into n plus 2, Now what is given here? An is equal to n into n plus 2, where you can take n is equal to 1, 2, 3, 4, etc. If you put n is equal to 1, so 1 into 3, that's equal to 3, right? Next, if you put n is equal to 2, 2 into 2 plus 2, that is 2 into 4, that's equal to 8. If you put n is equal to 3, then you will get a3 is equal to n is 3 into 3 plus 2, that is 3 into 3 plus 2 is 5, that's equal to 15. If you put n is equal to 4, 4 into 4 plus 2, that is 4 into 6, 6 4s are 24, right? Okay. Similarly, if you put n is equal to 5, what you will get? A5 is equal to 5 into 5 plus 2, 5 into 7, that's equal to 35, and so on. Now, just observe carefully, what is A1 here? Now, A1 is equal to 3. Now, what is A1? A1 is equal to 3. Now, just find out the value of A3 minus A2. Now, just what is A3 minus A2? A3 minus A2, what is A3? A3 is 15 minus 8. 15 minus 8 is equal to 7, it is 7. Okay. How to write this 7? 7 can be written as 4 plus 3. 4 can be written as 2 into 2 plus 3. Now, let us take similarly A4 minus A3. A4 minus A3. What is A4? A4 is 24 minus A3 is equal to 15. So, 24 minus 15 is 9. So, this 9 can also be written as 9 is nothing but 6 plus 3. This 6 can be written as 2 into 3 plus 3. Right. Now, let us find out the value of A5 minus A4. What is A5? A5 is 35 minus A4 is equal to 24. So, this is equal to 11. 11 can be written as, how to write 11? So, 11 can also be written as 8 plus 3. So, 8 can also be written as 2 into 4 plus 3. Right. Okay. Now, if you observe carefully, what you will get? A1 is equal to 3. What is A3 minus A2? 7. That is nothing but 2 into 2 plus 3. A4 minus A3 is equal to 9. That is 2 into 3 plus 3. And A5 minus A4 is equal to 11. That is 2 into 4 plus 3. Now, if you observe carefully, this is AN minus AN minus 1. AN minus 1 is equal to 2 times. So, this is 2 times AN minus 1 plus 3. See, here it is A3 minus A2. A3 is nothing but AN minus 1. 3 minus 1 is 2 is equal to, what you got? 2 into 2 plus 3. 2 into AN minus 1 plus 3. What is AN minus 1? So, AN minus 1 is equal to 2. 2 into 2 plus 3. Similarly, if you observe this A4 minus A3, the same relation you will get 2AN minus 1 plus 3. Similarly, for A5 minus A4, so 2 into 4 plus 3 is nothing but 2 times AN minus 1 plus 3. So, therefore, AN minus 1 is equal to 2 times AN minus 1 plus 3. That's it. Okay. This is for all n is greater than or equal to, for all n is greater than or equal to. This is very important problem for 5 marks. So, if you compare, if you observe carefully, then we are going to write this A3 minus A2 is AN minus 1 is equal to 2 times AN minus 1 plus 3. So, therefore, the recurrence relation for this is AN minus 1 is equal to 2 times AN minus 1 plus 3 for all n is greater than or equal to 2. That's it. Hope you followed. So, these are small examples on a recurrence relation. Now, let us come to the next principle, that is called the principle of counting. So, we have studied this all, I explained all this in the first unit itself while doing the permutations and combinations. Let me explain once again the counting principles. So, basics of counting, that is fundamental principle of counting. So, the factorial representation, let us know regarding the factorial representation. So, the factorial representation of n is denoted as n factorial or n factorial. The product of first n natural numbers is denoted by n factorial. So, whose factorial notation is n factorial denoted like this, n factorial or factorial of n, that is nothing but the product of first n natural numbers. So therefore n factorial is given by n factorial is equal to n into n minus 1, n minus 2, n minus 3, etc. Let us take one small example. The factorial of 5, 5 into 5 minus 1 into 5 minus 2 into 5 minus 3 into 5 minus 4 into 5 minus 5. So this is nothing but 5 into 4 into 3 into 2 into 1. Since 5 minus 5 is 0, factorial is always equal to 1. So therefore the factorial of 5 can be written as 5 into 4 into 3 into 2 into 1, and this value is equal to 5 4s are 20. 20 into 3 is 60, 60 into 2 is 120. The factorial of 5 is equal to 120. This is called the factorial notation. Right. Now let us take one more example. For example, if you want to write the factorial of 4, factorial of 4 can be written as 4 into 3 into 2 into 1. That is nothing but 4 to the 12, 12 to the 24. Suppose if you want to find the value of factorial 5 divided by factorial 4. What is factorial 5? 5 can be written as 5 into 4 into 3 into 2 into 1 divided by 4 into 4 into 3 into 2 into 1. These two gets cancelled, you will get 5. Or from the previous, what is factorial 5? 120, or this is equal to 120 divided by 24. The 24 5s are 120. Or suppose if you want to find the value of factorial 6 divided by factorial 4. So this factorial 6 can be written as 6 into 5 into 4 factorial divided by 4 factorial. So 4 factorial gets cancelled. This is equal to 6 5s are 30. That's it. This is some simple problems for 2 marks. Okay. These are few concepts regarding the principles of counting. So in this principle of counting, we are going to study regarding the permutations and combinations, and also the multiplicative theorem of fundamental theorem of counting, that is multiplicative theorem as well as the addition theorem. That's all regarding today's session. Let us meet with the different concept in the next session. Thank you very much.